Hi, I'm Vikramaditya Yadav and I'm a biological engineer.
Nature assembles, dismantles, and recycles molecules in the cleanest and most efficient manner imaginable. Engineers like me study biological systems in order to understand these remarkable natural processes and then use those insights to improve manufacturing operations and products. To a biological engineer, a forest is a source of both raw materials and information. We harness the chemistries in trees to make biodegradable electronics, as well as rethink how pharmaceuticals are discovered and manufactured. Biological engineers unravel the mysterious ways in which bacteria mop up oil spills, and we are re engineering these tiny machines to now rid our oceans of plastic waste. We are decoding how plants employ photosynthesis to capture carbon dioxide, and we are using this knowledge to design the next generation of chemical factories that consume and not liberate carbon dioxide. It is now possible to quite literally conjure things up from thin air, including lab grown meat. Yummy. The future belongs to the bold. The future will be shaped by chemical and biological engineering.
Hello, my name is Orlando Rojas. I'm a professor in chemical and biological engineering. Before coming to UBC, I have a long experience working on polymer chemistry. But life took a different turn, and now I'm working with materials that we find in the biosphere, mainly materials that we can harvest from trees. And trees we use in a sustainable manner to produce the materials of the future. And this goes beyond paper and packaging materials. We're doing research looking into the solution to future materials needs. The situation with the environment and climate change is a good motivations for us to do work related to the replacement of plastics so that we can ensure a more sustainable future in humanity. And one very recent example that is the tip of the iceberg has been, for instance, the replacement of face masks that are produced from polyolefins, petroleum derived polymers, using fibers that we take from trees. Trees help us to have a clean environment. Trees fix carbon from the atmosphere and therefore represent a very interesting source of materials. And in this case, we use fibers to make the face masks here in UBC that we think can be an important advancement as far as reducing pollution. I would be very excited to meet with all of you to share many more examples of how we use nature to produce the materials of the future.
Hi, I'm David Wilkinson, a professor and Canada Research Chair in Chemical and Biological Engineering. Our group works in the area of clean energy and clean water, two of the most important challenges that we face today. Did you know we will need to at least double the energy production by the middle of the century? The energy should come from clean, sustainable methods without affecting the environment or climate. We are looking for sustainable solutions that balance the environment and economic and social requirements. This is a big challenge, but it is what chemical engineers and engineers in general do. We are trying to tackle some of the world's biggest challenges and have an impact. In our electrochemical engineering work, we work with devices such as fuel cells, electrolyzers, and batteries, and in areas such as energy conversion, energy storage, catalysis, nanomaterials, and engineering design at different length scales. Today, we are focusing on batteries, which are critical for electrification of transportation. It is anticipated that the demand for batteries could rise by 2 orders of magnitude in the next 20 years. In our research in the Wilkinson Group, we look at aqueous or water-based batteries and non-aqueous lithium-type batteries. Research is done by senior research associates, graduate students, and undergraduate students just like you. You're going to have a small battery tour with Dr. Armin Bongnaktapur, a senior research associate in one of our labs at UBC. I hope you find it interesting.
Hi everybody, welcome to our battery research lab in the Clean Energy Research Center at UBC. My name is Arman, I am a research scientist who works here. I'll be giving you guys a quick tour of our lab and what it is that we do here. Let's look at some batteries that we work with and we test here in this lab. Here I have an example of a lithium-ion cell. So these lithium-ion cells were introduced by Sony company in 1991, and they've been increasing their energy density and the power that they can deliver ever since, to a point that all electric cars are using them. So for instance, an average Tesla car would be using about 5,000 to 6,000 of these cells. So what we are interested to learn in this lab is what the failure modes of these batteries are and how we can extend their lifetime. So to do that, we will need to put the cell inside a test board. So this is a precision test board that allows us to monitor and measure both voltage and current and also the battery internal resistance during cycling. Dr. Beijing Fang is another research scientist in the group. He's preparing some electrodes using materials that we have developed in the lab to be tested in the battery. So he has coated some metal foils, and now he will be spinning under a vacuum to get uniform deposition. In order to test the materials that we develop in our lab, we work with coin cells. So here I'm holding a simple coin cell. The coin cell has to be made inside a glove box where we monitor humidity and oxygen. Inside this box we have inert argon gas. We also reduce the humidity. Inside the glove box you can see it's quite busy, but here our PhD candidate Bingxing Zhou is putting a coin cell together. So you guys can see she has lined up a whole bunch of components, and then once everything is inside the coin cell, we will crimp it. So crimping machine is that blue machine you see there. All right, so the coin cell goes inside and it will get crimped, and we make one of those crimped coin cells which I showed you earlier. So this was a quick tour of our battery lab and the kind of things that we do here. I hope you enjoyed our quick tour and stay well.